All right, welcome back. Let's now finally get to our complete example. So example 2 reads that a previous study found that 37% of pet owners talk to their pet on the phone. A veterinarian was skeptical, so he randomly selected 150 pet owners and found that 45 do talk to their pet on the phone. Should the vet be skeptical? In other words, is this sample evidence at the 5% significance level to suggest that the proportion of pet owners who talk to their pet on the phone is lower than 37%. So there's a lot happening there. I went ahead and put this little summary for steps to any and every hypothesis test that we will be doing in this class. I really want to encourage you to start by identifying the parameter. Remember, parameter means a population value. So for us, it's always going to be mu, sigma, or p. And I know the title of this kind of gives it away because this section, 5.1.2, is all about parameters. So there was a lot here that was mentioned. And notice they're talking about pet owners talking to their pet on the phone. So I don't have a pet, so I don't know if this is strange or not. You be the judge. And so the variable of interest here is whether pet owners talk to the pet on the phone or not. And that's clearly qualitative. Because of that, you know that this will be a proportion. Okay, so the parameter of interest here is P. The proportion, the true population proportion, of pet owners, and I'm just going to put ... because it's what I underlined in purple. Talk to the pets on the phone. All right. Now, they kind of give you a lot. They're summarizing the sample for you. Try not to get so hung up on the fact that you're already sampling. You need to set this up first. So we already identified our parameter. Next, you need to write the hypothesis. As soon as you know that you're talking about P, the true population proportion, that has the trait that they're talking about, go ahead and write out your hypothesis. It's always going to be, what is the current claim for that parameter? Okay, so my hypothesis is going to be H0 is that P is equal to something. And the alternative is that P, and it's for us to determine. So what is the claim here? It's always going to start with a claim. Can't really do much if you don't have the claim. Anyways, this is a previous study found that 37% of pet owners. So I'm going to go ahead and say that P right now is 37. So I don't know any better. That's what it was true in the past. Remember, 37%, whenever you see the percentage, just go ahead and divide that by 100. Don't just feel like moving the decimal over just because. A lot of people, for example, if we were doing a mean and the answer was 37 and there's no percentage, people tend to move the decimal. So just make sure you don't do that. But anyway, we got that P is 0.37. And the question now becomes, what is the alternative that we are trying to show evidence for? So what the vet was skeptical. And then it goes on to read, takes a sample, should the vet be skeptical? In other words, is there evidence to suggest that the proportion of pet owners who talk to the pet on the phone is lower? So that'll be a left tail test. All right, and so there it is. I have my hypothesis. Now we can essentially go ahead and throw this into StatCrunch, but remember, this is like writing an essay. You need to go ahead and have all the setup. So part of this requirement, this is something we haven't done, but it's because we did it in the previous chapter. Everything else we've already done is to check the conditions are met for the sampling distribution. This should be very familiar to you. Remember that I'm basically writing a sampling distribution here. We're assuming that a sampling distribution describes how samples behave. So we need to go ahead and check the requirements that we saw in chapter 8 and 9. And remember that those were, you need a simple random sample. So let me write it here. And you need independence. And both of these are safe to assume. Again, independence because our population tends to be very large. The one thing we do need to check is the shape requirement. So let's go ahead and check n times p times 1 minus p. Is that bigger than 10? N is given to you. This person took up randomly selected 150 pet owners. P, hey, that's this guy right here. Right? Just kind of look at your work and say, hey, do I know what P is? Yeah, the null hypothesis. We're saying that P is 0.37. And then 1 minus that. All right, go ahead and throw that into a calculator. And as soon as you write down the number, you just want to observe that it's bigger than 10. Okay, and so we can go ahead and check that off. So definitely make sure that you check this because it's really important for you to ensure normality. All right, so check this out. We've got our parameter, hypothesis, condition. So that means that we know that the sampling distribution is in fact going to be normal. So let's continue sketching. So now that we have the shape, we're going to go ahead and set up our distribution. Okay, so remember, for proportions, it's a Z, standard normal. All right. My alternative hypothesis is a less than. So that means that this will be a left tail test. So I want to go ahead and sketch the left tail, shade it in. And so that right there is statistically significant. So that's alpha, significance level of 5%. So we read it here. 5% is 0.05. And I can go ahead and find the critical value. So let's go ahead and find the critical value. And remember, your training, hopefully by now, you are used to marking this, and therefore you can put a little empty box here indicating that you're going to find it. So remember, this is going to be Z sub alpha. This standard normal, Z, so that's mu is 0, spread is 1. And let's go ahead and find this critical value. Always set this up ahead of time. Stats calc, normal, mean is 0, spread is 1, perfect. I've got the left tail, and I need to get 0.05 in my tail. So that's negative 1.645. Remember that this region here is the rejection region. You're getting samples that are too unusual. If you don't land in there, then you don't reject H0. So now finally, we're at that point where we're going to find our sample statistics. So remember, the sample statistics, we're going to go ahead and say, okay, my sample now can be used to find the test statistic, aka the Z test, and the p-value. So I'm going to go ahead and find both. All right, and here's the awesome part. To determine the sample statistics, it's very simple because we're simply going to go to stats, proportion stats. We're still dealing with one sample, right? Because this is a single sample. And just make sure you select hypothesis test. And that's about it. So we really only need StackCrunch for this in red. And this is the only new item that we have not seen. So let's go ahead and try this out. Or stats, proportion stats. I know it's proportion stats because I'm dealing with proportions. One sample, and we have a summary of the results. Right? They just summarized this for us. They selected 150 pets. They found that 45 talked to the pet. So there were 45 successes out of 150 individuals. And that's pretty much it. That's all I need to tell StackCrunch. I need to make sure that my hypothesis matches because this is used to get the test statistic, this P0. So we need to make sure that we get the correct value in here. Always make sure that StackCrunch matches your paper. So I have my hypothesis here. That's H0 is P is 0.37. So that now matches. It automatically populates the bottom, so don't mess with that. And we believe that it was less than, so that was a left tail test. This now matches the hypothesis that I wrote. Press enter, and you get your values. So all of this is familiar from the previous section, sample proportion, that's p hat, standard error, that's sigma of p hat, estimate. Oh, actually, for this one, it's not estimated because we're using this one, 0.37. Here's our z statistic and our p-value. So let's jot those down. All right, and now finally, the moment of truth. So we need to go ahead and make a conclusion and interpret. So for your conclusion, always sketch where this lands. So I always like to emphasize where my sample lands. So remember, that's what the z-test is for. Negative 1.7, that's where you land on the number line. This is 0. This is negative 1.6. So negative 1.7 is further out to the left. That's our sample. So again, if you're doing the z-stat, we're going to go ahead, I guess the condition would be, now you can compare. So the pink dot is z-test. And you can see that z-test is less than negative z-alpha. And that basically means that we're in the critical region. We're in the critical region, and so therefore, we have a statistically significant sample. My sample is not expected to occur under the null hypothesis. All of this that we have done was under the null hypothesis. So again, we're just assuming it's true and then kind of seeing what the evidence says. Let's take a sample and let's see where my sample lands compared to that claimed center. And so we can see that we're very far away. So again, we're going to reject the null hypothesis. If you want to do a p-value approach, you compare the p-value to 0.05. Just kind of match up the numbers. 3 is smaller than 5, so my p-value is smaller than than alpha. So the p-value approach, you would say p-value is less than alpha. And it makes sense because remember, p-value, you would shape this in, find the area to the left. And so that would be the probability that a randomly selected sample would be to the left of the sample you picked. So in other words, it quantifies how unusual your sample really is. And again, whenever p-value is less than alpha, we reject A0. All right, so finally, let's go ahead and interpret. So reject A0 is the conclusion of the hypothesis test, but now I need to interpret this, right? I need to speak English now. And so we're going to say we have sufficient evidence now. Always tell me at what level, because the alpha level tells you how unusual the evidence needs to be. So I'm going to say at the 0.05 level of significance, to say or to support the alternative. And remember, that was the claim that P is less than 0.37. So don't say P, go ahead and write out what P is in words. That the true proportion of pet owners who talk to their pet on the phone. Anyway, it's, again, just whatever P was, is less than 0.37. So my sample supports the claim that the proportion is actually smaller than it used to be. And that's about it. So here we have our first full hypothesis test. Take a look at it fully. All of this work is required for every single hypothesis test, right? We want to write the parameter, the hypothesis, check the conditions, sketch and label everything, and finally get the test statistics so that you can interpret. So take a look at this example one more time and go ahead and try example 3 on your notes, and then you can check out the next video.